course of the closest approach is what you are going to see. But here, it's very easy, but you need to take these points very, very careful. It's different from course of intersection. This is a course of the closest approach. Okay, intersection, of course, that is very easy to say the course. You just need to know where someone is going, then you set the course towards that direction. But now this one is a bit different. If A is to pass, not who is to pass close to who. If A is to pass as close as possible to B, so now A is the one to pass as close as possible to B. Then velocity of A, the velocity of A should be perpendicular to the relative velocity A, B, B. So the velocity of this one, which is to cross as close as to the other, should be perpendicular to the relative velocity of the two. I.e., when you dot these two, you should get 0. The closest distance B from B should also be perpendicular to ABB, and ABB is from A. This is the idea. You start, this A is to pass as close as possible to B. It means that now the relative velocity of these two is from A, and note that ABB should always head towards the negative of VB. Now, if this one, we are assuming that this one is its velocity this side, then the negative of VB, that's where A should always head. Now, you said this one is perpendicular to the velocity of A is perpendicular to the velocity, the relative velocity as you see, and this perpendicular or the shortest distance is also perpendicular. Of course, the shortest distance is always perpendicular to a point or where it's. So that is also perpendicular to that in that case. So this implies that now the velocity of A and the velocity of B, if this is the velocity of B in this case here, VB, then this one is the negative velocity of B, the opposite direction. And that's always, so that this one should always be, this one is say, VB should always head towards, as you see, it's heading towards that. When you know these ones, the rest are going to be very the same. Let us come to this question. Two cars A and B with B traveling at a constant speed of 10 meters per second due east, and A is traveling at a constant speed of 8 meters per second. So, initially A and B are 600 meters apart, with A due south of B. So we start with that. And then that's that A is due south of B. So now, if we have a sketch, if this is our B here, if this is our B, they are telling us that A due south of B. So due south of B, this is the due south. So when we stop there, it shall be our point A. That is the idea. So the distance between them, here the distance is 600 meters. They are 600 meters apart. This is the due south. I think this is due south. If this is our north, this is the due south. Okay. They're telling us that B is traveling at a constant speed of 10 meters per second due east. So this one is traveling due east. So this is the velocity of B, 10 meters per second due east. And A is traveling at a constant speed of 80 meters per second. So now they are going to give us the direction. 600 degrees south of B. Find the course A should set in order to get as close as possible to B. Now we start with A is that which should pass as close as possible to B. The first thing we do is to look out for the negative of B, because our negative velocity is always heading towards the negative of AB. Now when I do this, I think you can say the negative of AB is, the negative of BB is going to be in this direction. So this is our negative of VB. Now, it means that now the relative velocity, we say that the relative velocity VAB, ABB is from A where the distance we want A to be supposed to pass as close. So anti-velocity is always from this one, so then I do that as you see is from there. And we said that now the shortest distance from B, this is going to be our shortest distance from B, which we are going to say, let us call it B. This distance is B. From there up here is the distance B. As simple as that. Now, this one now is what we call A relative to B. Always, the one who wants to pass as close is always A relative. You see this one is one which wants to pass as close to this. So that's why we have A, B. Okay, that's the first case. Now, it means that now we say if this one is this side the same, you see that this one is the relative velocity and this one is coming. It means that A should come and then go this side. If this is the relative, it means that it's going in this direction and the negative of this going in this direction. It means that A should come, then come this side, so that it's in that direction. Go, then come this direction. So means, which means that now our VB, our velocity of A is in that direction. When you come this side, you see it's in relation to this one. And you say it's what? It is perpendicular to the relative velocity. Now, if this angle here is theta, the angle that this relative velocity is heading towards the side, it means that now the remaining angle here is going to be 90 minus theta. And now, if we know that all of this is 90, from here up to here 90, so if this is 90 minus theta, it means that this one is going to be, this one is going to be theta. Now, if I'm to reconstruct this here, if I'm to bring this as close to this here, you are going to see that if I try to bring this, okay, let me try it here. So let me first construct this, then I'm going to bring this close. So what we have this, then we have our VA there. So these two are perpendicular. This is my A relative to B, and this is my velocity of A. Now, if I bring this and I put it here, you see this one I'm going to be with. Hope you can see that. So this is going to be the negative of VB, which is equal to 10 meters per second. The magnitude doesn't change, it's the direction that changes. That's why this is 10. And this one, they told us that the velocity of A is 8 meters per second. Now, the question is, what is this angle? Now, if I'm to bring you back here, I think you can see this. If this angle here was theta like this, it means that now also this one is going to be what? It's going to be theta. So now, my interest is to get this angle here, theta, which we can get with ease. So, when you finish that, the rest are going to be very easy. I think you see, I have this, I need this. So this is adjacent, this is hypotenuse. I think we can see that is hypotenuse. So meaning, from there, you have adjacent, you have hypotenuse. So from there you can see, and now my cos theta is going to be the adjacent, which is 8 over 10. So from there, my theta is going to be, so it's going to give me 36.87 degrees. Now, this is theta here. You know that my cos is always, this is the cos I'm going to set, this one from here. So my cos, we already set it from the north. So this is the cos I want to set. So the cos to be set, the cos to be set is 90 minus theta, which is going to give us, it's going to give us 53.13 degrees. That's going to be our answer. So that is the cos. As simple as that. Once you know the basics, the rest are going to be very easy. Let us come to part B. the closest distance. The closest distance, from here you can see the closest distance. This is the closest distance. So if we have this, we see that this is, if I come to this now, if I come to this, let me draw it here. I think you can maybe see it. So this is my theta. Remember, the whole of this is 600 meters. So this is my B. I'm interested in the closest distance there. I think you can see we have our theta. Our theta, the whole of this is what? 36.87. So I have adjacent, I have hypotenuse, I have the opposite. So from there, you can see that now my sine, this is hypotenuse, this is adjacent, and this is adjacent, this is opposite. So I need this, I have this, I have this. So hypotenuse, opposite, that one means we are going to use sine. So from there you can say my sine 36.87 is equal to the opposite over hypotenuse 600. So from there my value will be 600 sine 36.87. And so our closest distance is going to be 360 point, yeah, that is it by now, in meters. 0.0 in meters. Is it in meters? Yeah, in meters. Okay. And the time for it to occur. Now, for it to occur, it means the time we need from here is the distance. So we need this distance. If this is the point C, and this is our A there, it means that we need this SC. We need the distance SC. And if after getting this is the distance now we need, this is our C, and this is our A. But remember here we have our relative velocity. So to get the time to cover this distance, remember the distance to cover to be as close as this, we have covered this distance SC. But we're using the relative velocity of A, V, B. So meaning we need AC and we also need this relative velocity. So from here, okay, allow me to cross this in here. So from here you can see that we can get this here. So you can see I have this as the opposite, I have this as adjacent. So I have this theta now. So I have this as the opposite, I have this as, anyway we can use, but we need to put in this because we have this, we need this. So where is that? This is opposite. So now my sine of 36.87 is equal to the opposite AVB over the hypotenuse, which is 10. So from there, my AVB is going to be 10 sine 36.87, which is 6. It's giving me 6 meters per second. Or from here, you can use Pythagoras. You can use Pythagoras. You have this, you need this. It's up to you. Now, how am I going to get my SC? So meaning that my time is equal to SC over AVB. So how do I get my SC? Not from here. Can you get SC? From here is that you can able get SC. I think you can see that our S is going to be AB cos O. If you don't want that, you can come and see that because I did the S, so it's adjacent, and this is going to be hypotenuse. So it means that now I need adjacent, I have my hypotenuse. So I'm going to now my cos theta is going to be adjacent AC over this one. Remember, this is our B. Isn't it? Yeah, this is our B. Over adjacent over AB. So which implies that now my SC is going to be AB, then cos theta. As you can see, that's why here I'm going to say this is going to be AB cos theta all over AB. B. So here my time now will be, this one is going to be 600, then cos of 3, 6.87, the whole over 6. So here our time is going to be so here, I'm getting 8 seconds. Okay, I'm wrong enough, but that will be the answer. So, as simple as that. Once you can digest this information, the rest are going to be very good. That's it. I wish you well.